Okay, it looks like we've got a fair number of people joined the session. I'll uh, go ahead and sort of start with an introduction today about the topic, and we'll go ahead and jump right into it. Thank you for joining. Again, my name is Brian Jones. I'm a customer success manager for EDX Wireless. And today, what we'll be looking at is using our automatic site selection tools available with the LoRa IoT module, or also available with other technology modules such as LTE or NB-IoT or LTE-M. If you're using a different technology than LoRaWAN, and you still want to look at automatic site selection, this potentially will still be relevant material for you because it's really the same feature sets. In regards to the automatic site selection, it's largely the same feature sets for each of those different technology modules. But the use case we're looking at today will be a LoRaWAN based use case. And what we're going to be looking at is going beyond using just the automatic site selection to simply cover the area or cover the subscribers with the fewest sites possible. That's sort of level one of using the automatic site selection. And we'd like to look at some of the other features and how we can get more out of it, especially in regards to cost. So in the use case today, we'll be looking at designing for uh, coverage, of course, but also capacity and most importantly, cost. Um, in the use case, the challenge that we're looking at is that we've got a municipal IoT smart city sort of deployment. And a lot of these projects, you potentially have a large number of candidate sites for where you could place a gateway or a backhaul for the network. And this can be a mix of assets like streetlights or utility poles, in addition to traditional cell towers, or maybe even buildings that are owned by the municipality, and you could put a mast on their roof. You might have a whole different mix of assets that come with their own sort of costs to deploy on them. And you have multiple criteria that you're being asked to design to. On the one hand, you need to ensure, of course, reliable downlink and uplink coverage to all of your endpoints. And then we also want to make sure we have sufficient system capacity for the number of endpoints and their type. If we've got different traffic loads represented by different types of endpoints. And the goal very often, if we've got different costs for deploying on these different assets, the goal is not just to minimize the gateway count, but to minimize the overall cost of getting to the level of coverage and reliability that we need. And so the solution is to use the cost-aware features within our automatic site placement feature sets. And again, any of those are built into your EDX network design modules. And I'll jump over to the software real quickly here to just show you what I mean by those modules. So we're looking at the latest version of SignalPro here. And over on the left, we've got the mobile cellular module, the WiMAX wireless broadband module, which also covers things like Tirana and some of these other broadband products that use a proprietary OFDM. And then we've got our LTE and our 5G modules, Wi-Fi, LTE-M. Any of these same feature sets that I'll be looking at today are available in all of those modules. So if you're looking at one of those technologies, you can apply the same concepts and the same feature sets here. And then over on the right-hand side, we've got the NB-IoT and the LoRa module, which also they've got the exact same feature sets we'll be looking at here today. And we've got automatic site placement and automatic mesh repeater placement within our mesh module. So these concepts and this cost-aware functionality is built into SignalPro and the add-on modules in such a way that whatever technology you're looking at, you can use these same strategies to try and find a low cost selection of sites to reach the coverage metrics and the reliability metrics that you need. So jumping back to our slides here for just a moment, we'll take a closer look at this use case where again, we've got a smart cities deployment, and I'll jump back to the software here. The area here is San Diego, and it's a subset of San Diego here. If I go ahead and show my Bing map layer, we can see we've got some sort of more urban core section. We've got some residential, and there's really an awful lot of difficult terrain in the area. San Diego's got these deep ravines that are difficult to get coverage down in. And to sort of take a look at the initial starting point here, what I have my blue towers layer here, all these blue points represent those utility poles or other site locations where I could potentially put a LoRa gateway. And in that list, I've got a mix of both utility poles with one cost associated, and then also here, I believe I actually made these as sites just to take a look at them. If I go ahead and show my costly sites layer there, this group of sites, I put those in as towers or maybe buildings that could be deployed on, but they would carry additional expense with them. Um, and we'll talk as we go through it about how we import that and how we represent that in the data set. But so we have potentially these buildings, and then also all of these utility pole locations or streetlight locations that we could use to serve this area. And we could look at the area just in sort of an area-wide capacity where we're just trying to cover the whole area if we don't know where the subscribers are going to be. But it's more efficient, of course, and we can do a faster placement and perhaps a more targeted placement if we know exactly where those end device locations are going to be. And in this project, actually, I sort of looked at it both ways. I can do it based on area-wide results is what we'll look at here today. But you can also do this based on a fixed point to multi-point. And of course, if we've got a fixed point to multi-point, even if we've got thousands or tens of thousands of endpoints, that'll often run more quickly. The auto placement as well as the studies will run more quickly than a nice high resolution, area wide study like this, a heat map type study to cover the area. Looking at it this way might be less efficient than just looking at the actual fixed endpoint locations. So that's one recommendation I have. If you're going into one of these projects and you can get the lat long for all those end devices, it really is worth it to bring it into the software and do it that way. Oh, I guess I was also going to show here that we've got some pretty complex clutter. We've got trees as well as treed residential areas and downtown core and all that sort of thing. Um, so what that means is that any one site location or pole location might have radically different coverage footprints. We might get a really different cell edge from one pole versus another. So they really all need to be analyzed with a real propagation analysis to figure out how they might contribute to the solution. If we were just doing this over cornfields and it was completely flat, maybe the need for planning is not as important, or the site selection isn't as crucial. But especially the more terrain variability you get, and the more clutter variability you get, the more important it is to try and do this planning with a real propagation analysis for every candidate site. Um, so let's start out by looking at how we get this input data into the project. So of course, as you can see in my project here, I've already gone through the steps of setting up my terrain database and my land use, land cover. There are those layers. I've set up a propagation model that I'm happy with. And I went and set a template up for what my LoRa gateway looks like, and also what my mobile remote unit, if I'm doing an area-wide type of study, or what my CPE types look like if I'm doing a a fixed point to multi-point type study. And you'll notice here we can put in data rate demands if we want. So we could have different types of endpoints with different data rate demands to plug into that automatic site selection function as well. And if I want to, if I've set up my CPE type and I want to just automatically set up the mobile remote unit, you'll notice in the latest version of the software, there's a button down there to do that now. So you can just set it up once and then transfer it over to the mobile remote as well. Um, Going a little bit deeper on setting up the LoRa details, in case you're new to the LoRa module, the way that we designate a particular sector in the project is going to be a LoRaWAN sector, is we go here under system name or type, and of course I drop down here and select the appropriate system type for LoRa, instead of generic transmit receive, which if you're using a SignalPro only license without any modules, you may have gotten used to using this generic. But if you're using, LoRaWAN, you would select here, or NB-IoT. If you're doing LTE, you would select LTE Pro. And then you want to go up to the appropriate section under the Network Design Analysis menu and define the details for that technology and which band you're using and all that kind of thing. For LoRaWAN, it's extremely easy. Once I've set some sectors and also my base station template is used to set, that system name or type. Uh, of course, I also need to make sure the link budget details are correct in my site properties. So my transmit power and antenna gain and all of that stuff, I'm going to put that into the site template as normal. But then I'm also going to go up to network design, and under IoT networks here, we find LoRa. And if I go into system details and service area, for the LoRa networks, the system profile is extremely easy. You just go ahead and grab the modulation table you're using. If you're in a different market, if you're in Asia Pac or something like that, you can edit or create these tables, but also we'll be adding those other tables in an upcoming release here. And if I go ahead and look at that, what this is showing me here are the different LoRa spreading factors and bandwidths and so forth, along with the transmit power offsets that are used for that, LoRa deployments within that region. And so this is all from the standard, and you don't really need to tinker with it. You can if you want, but it's all sort of built into the chip. If you set it for US deployment, then it's going to be using that spreading factor table. Um, so having set that up now, I'm ready to go ahead and set area studies or multi-point studies specifically from the LoRa system group. And here we've got data rate for uplink and downlink. We've got bidirectional margin, which is it's going to look at the required service threshold for both the uplink and the downlink case. And it's going to tell you how many dB above or below that the lowest of those two thresholds is. So that's a good way of seeing just how much sort of RF headroom you have in a particular location or at a particular endpoint. Um, Optimized uplink transmit power. is looking at, okay, for the spreading factors that these are going to be operating at, what's their average transmit power going to look like? And that can be important if you're trying to determine battery life on a battery operated device. I think probably the most relevant study, the one that's kind of the most at a glance metric of reliable performance, is going to be this number of LoRa servers above uplink threshold. And there it's simply reporting how many gateways can make the uplink link budget. So how many gateways can an end device talk back to successfully? And if we look at my I've got a selection here based on my auto placement with a few more polls, and we'll drill into those results and how we came to them later on. But let's see from that. I gotta consult my slides and make sure I'm not getting off track. Right. So from this list of gateways set up with their correct link budget and everything like that, we can go ahead and run the auto placement to get this site selection, and then we can run some different studies to show reliable coverage. And just as kind of a hint at the conclusion here, we came up with a pretty darn reliable coverage across the whole area. And let's look at how we got to that. The first stage again is importing those tower and pole locations. So once I have the rest of the project set up, I've got templates for the equipment and an environment and propagation model I'm happy with. Then I can go ahead and go into databases, towers, and poles. And here we've got some tools down here lower in the dialog to create some poles if you just need to make poles along the streets or something like that. Or you can also filter poles. So if you need to just filter out the poles within a particular area or subsample them down because they gave you a million poles or something like that, that's what some of these filtering functions are for. But most of the time, what you'll do is just go ahead and import from a CSV file. If you have the costs and you have different heights for your poles, you'll want to put all of that into an Excel type comma delimited CSV file. And then in this import function here, you'll have a place to map which columns in your file go to sort of which data in the tower and poles format. And if you go ahead and use this import tool, and you'll see a little green checkbox down here once you've actually imported the poles, and then you can save those poles into a what we call a towers and poles file, which looks like this. Uh, I apologize for the background noise. I'm in Seattle and we have fighter jets going overhead, so I apologize if that noise is coming through. This is an example of what our towers and poles file looks like. And what we've got here are a longitude and a latitude, heights above ground level in meters, and then an identifier that comes in the quotation marks here. And this final digit is a cost factor. So just to keep the math simple for myself, I went ahead and gave my tower and poles, or rather my street light locations, gave them a cost factor of 1. This could be real dollars if you wanted, or it could be kind of whatever units you want to use. But the important thing is the ratio between the costs. So I've said, okay, it'll cost me a 1 to deploy on a streetlight, but it'll cost me 10 times as much to deploy on these other locations that are taller. The idea here was that we had some towers up on rooftops, and yes, I could deploy on them, but maybe I have to pay lease costs, or maybe there's more cost associated in using those towers. So the question becomes, well, does this extra height, does the extra connectivity afforded by these towers offset that additional cost so that they're still a good deal? And so I've pointed to that, oops, got to get back to my software here. Pointed to that towers and poles file that I created, or rather imported through the CSV function here. And then to see that on the maps, I've just added the towers map layer here so that I can see those. Now at this stage, if I just wanted to run the placement for the entire area, I would put in a service area polygon, or I would create a service area polygon, maybe with my draw polygon tool. And then I would go over to the network design analysis, and you can use this auto placement for areas. And if you use the auto placement for areas, it's going to look at each grid cell within your study grid and within your polygon as an endpoint to be served. And it's going to be trying to serve all of those endpoints, which can make it a little hard to do the capacity portion of it. So instead, if I can, I would like to go in and import my CPE customer terminal list. And of course, that's the end devices or the sensors out there in the city that need to be reporting back to the gateways. And I will go into the RF systems, spreadsheet editors, and CPE data to go ahead and import those from a CSV file as well. And again, if I have different types of CPE with different data demands, I can import those as groups. I can create a group of maybe streetlight controllers versus traffic cameras or audio sensors, or there's all kinds of different things you can do that would have a different data payload. So if I need to, I can include different types of devices. In this case, I kept it simple with just one. I'm going to be talking over those fighter jets, I guess. So since I have those endpoints that I can try and use for my auto placement instead, the auto placement will go more quickly and I can keep track of the capacity much more easily. So what I'm going to do now is go to Network Design Analysis, Multi-Point and Backhaul Networks, and then Create Hub and Transmitter Group. And there are a couple of different methods here. The interactive hub layout method is like the really old school way of actually seeing hexagons on the map of a given radius and trying to select sites nearby. We're not really interested in either of these. The initial layout function. Where we want to go is this automated hub layout method, an automated router selection here. And you'll notice I've chosen a CPE group. If I have different groups of CPEs, then I can pick one of those, or I can just pick them all. And inside automated router selection, we have a couple of setup details here we need to look at first. Let me just make sure I'm not skipping anything in my slide deck. This is for me, not you. Okay, so in the initial setup here, under the propagation selection, if I go in here to set up propagation, you can see I can choose one of the propagation models that I set up in the main program, but I can also override the lookup spacing and make, especially if you've got hundreds of thousands of candidate locations, you might use a lookup spacing that's a little bit less granular just to make the calculation go faster. And it'll do that initial placement, and then you can calculate finer results in your finished predictions. So that's what I've done here is I've given it a lookup spacing of 25 meters, and it's going to look out from the gateways at a granularity or a point spacing of 25 meters using my Anderson 2D propagation model and pass through clutter loss for things like foliage screening and buildings. Under the router candidates, I've just selected use poll database because I already went ahead and imported that poll database. There are options here to do it from a CSV file, or if you've already created some sites in the project and the question is, can we operate with just a subset of these sites? Then you could use the existing hub group and choose a collection of sites. Um, I've gone ahead and just used my poll database. And then this reduced CPE sample size, what this will do is look for CPEs that are close to each other and try to reduce the overall set of points that it needs to serve in the auto placement calculation. And that's, you notice it's telling me that I have 495 CPEs on the map at the moment. The only time you need to really do this reduced CPE size, sample size is if you have hundreds of thousands of CPEs and hundreds of thousands of candidate poll locations, then it really helps speed things up to reduce that sample set so that you've still got a representative distribution of the endpoints, but you don't have to try and serve every single last one in the auto placement calculation. Most of the time, you can skip this stage entirely and just jump right down to run auto placement calculation. And there are a few options here, and I'll jump over to the slide to make sure I'm not missing any, and perhaps this is easier to read as well. There's a checkbox up at the top here for use installed routers in the selection process. And if this is a greenfield deployment, then I would leave that checked off. I just want to use my tower and pole candidates and find the least expensive solution. If this is an existing network where I already have gateways out in the field, then when I do my placement, ideally, I want to leave those existing sites in place and find a selection that either improves the capacity or fills in those areas that are not covered by the existing sites. So if you check on that use installed routers, then you can select a TX group of those sites that are already out there in the field, and it will assume that those sites are part of the solution and choose from the tower and pole candidates sites that would augment the coverage of what you already have out there. So this is great for expanding existing networks. If the city comes back and says, okay, what about adding this other subdivision, or we're building new subdivisions or something like that, you don't have to rework the entire solution. You can just pick sites that naturally complement the sites you already have out there. Um, right here is where I'm just inputting a new transmitter group name, and I'm selecting the site template for what I want those new sites to look like. I can set the maximum router range here where I set this value. It's important to understand that's the maximum range that you even want to consider propagation from a candidate site. We're not saying that we expect 10 kilometers of coverage from a site. We're saying this is as far out from the site as we should even bother calculating a result. And if you set this very small, the calculation will go faster, but you might not get a very good result if the site is actually capable of transmitting out to 10 kilometers, but you've reduced it to 5 kilometers, you're going to get more sites than you need, potentially. So you want to set that range to a reasonable maximum range for the device and the threshold that you're looking at. I set the threshold in dBm here, and this is a downlink threshold, so it's important to figure out what your maxima or your minimum allowable downlink threshold is to have an acceptable link budget in both directions. And now we have an option here whether to just use the meter or cell count for capacity. And so, in other words, this is the number of endpoints we're serving. And we can use that as the numbers for capacity, the units. Or if you check use traffic for capacity, then back here in the software, if I put in some different data demands for my CPE types, it will use those demand numbers so that, a sector can only serve so many megabits per second. And it'll use those demand numbers and the activity factor to calculate how much that demand is on average. So jumping back into my multi-point auto placement, we've got four different methods here. Actually, I will go back to the slides. They're bigger there. So we've got four different methods here. And to break these down, the method one is a purely coverage-driven method. It's trying to cover the necessary area with as few gateways as it can find to do that. And I just put in the percentage that I'm trying to get to. Or if I've got a number of endpoints, if I'm doing this multi-point, it'll be 95% of those endpoints themselves. Um, this is the fastest automated router selection, although usually the limitation is the propagation for that number of points, and the different methods and how long they take to calculate is not really substantial. So the coverage limited router selection, I really only recommend to use that in cases where there's really no difference in cost between the different gateway locations, and the capacity is not a real issue. If you don't expect to have enough endpoints to have capacity issues, then this method one is going to be just great. If we're looking at capacity limited systems, you can use either the methods 2 or 3 here, and you can give it a maximum number of CPEs served, as well as the orphan CPEs. It's sort of the minimum CPEs served. And then the method that we find ourselves recommending the most often for these more complex scenarios where you're looking at capacity and cost is this method 4, capacity planning with local greed, which is sort of how our developers distinguish between these different algorithms. But let's look at the results that we get from this. And I'm not going to make you sit here while we watch the progress bar for the calculation. Um, I will take a look. So if I were to go here and press this method for capacity planning for local greed, I'll get to this window here where I have a set of variables I can set up. And then down below in this lower window is where the results from the auto placement are going to show up. So let's take a look at those. Um, my router range and my threshold, those get pushed in from the other dialog, as well as the maximum and minimum capacities. Those come in from the other dialog, but you can modify those here as well. So here we're saying I don't a gateway cannot support more than 5,000 of these devices. And the minimum capacity, in other words, don't create a gateway if it's going to serve fewer than 10 endpoints. And so those are some limits that you can put on, and it will try to get enough gateways to serve that capacity. In the use case that I'm looking at, I didn't make capacity a player in this. I gave the gateways plenty of capacity for the data payload so that we could look purely at the cost differences between solutions. Um, let's look over here at the stop conditions. This is, the algorithm when you hit run optimize capacity planning, it's going to go through until it finds a solution that meets these conditions. And so I've had it stop on a particular percent coverage. You could also have it stop when it hits a certain number of sectors or gateways. And if you wanted to, if you're keeping track of the cost, both for the router equipment, which is here, the default cost, and then also the site locations themselves, then you can have it stop when it hits a total cost number. So if you have a hard budget cap, you could have it stop when it hits that cap. Generally, what we look for is to get to the coverage metric we need with the lowest overall cost that we can find in the solution. And if I check on this use costs for planning, here, I'll jump back to the dialogue here so you can see this. It can be difficult to wrap your head around the kind of ratios in the costing algorithm. And so, what what it comes down to is a minimum router capacity per cost ratio. So, how many endpoints is it supporting for its cost? And that ratio determines whether a gateway is worthwhile or not. And so in the setting up the costing, you can click this button to get sort of a default, but then you can, and that's based on the units that you've set for the value of a connected endpoint and your default router cost. But then we can slide this slider around and basically uh, all the way to the left is going to give us a lower capacity per cost ratio, which means ultimately we'll get more gateways. And if we slide all the way to the right, we get oh no, do I have it backwards? No, it's the right way around. We have a lower capacity per cost value, which is going to be, it's going to be more stingy with the gateways. I generally run this over more to the left-hand side because I need to get to that 95% coverage metric. And it's still going to try and find a solution where the overall cost is minimized for its solution. So all that to say, you don't really need to torture yourself about where exactly this slider should sit. You can run these and, compare one solution to another or compare one solution to the coverage-based solution and sort of see that it's finding the most efficient collection it can to get us to that 95% or whatever the coverage metric is. So let's take a look at the different results that I got. I won't make you sit here and watch this thing run, watch the progress bar. But what you get when this does run is your results will pop up, and each one of these little X boxes represents a proposed gateway site. And if I check on this X toggle mode, I can click those gateway sites on and off, and the colors around them are sort of like a best server plot, and you'll be able to see what becomes isolated, what happens to the coverage if you take one of these gateways out. And you'll also see that over on the right here as you select different collections of these or even use the add button and select a different tower to say, what if we add this one here? It'll show you the overall count of gateways and what percentage is going to be covered by that, as well as the the utilization. That's the number of endpoints served, which in this case we're looking at big numbers because this is an area-wide placement, you notice. In order to have a prettier picture, I went ahead and did the selection based on an area-wide. Um, but these results bear out pretty much the same way whether I choose the area-wide or the point-to-multipoint mode. And what we see here is that in the method one, so that simple coverage-based selection, there's this rec gateway and there's this Comstock gateway. Those are two of the towers that have that greater height, but also greater cost associated. The method one auto placement doesn't know anything about that greater cost associated. So it saw those two really tall towers right out in the middle of the flats and went ahead and grabbed them because they cover quite a number of end devices and it makes for uh, a lower server count. We have 29 sites in this solution, but based on just the costs of the towers alone, we won't look at the equipment costs because I wasn't really figuring those in very carefully. But the tower solution has an overall cost of 47 here. Whereas if we jump to the method four, the cost aware method, In this one again, I used or I think I left the gateway cost, the equipment cost itself, quite low, so that we were comparing really just tower locations. And in this one, we have 42 sites. So we have a larger number of sites, but we're covering a little bit greater percentage of the area. And crucially, the cost of those towers is less. You can see all of these sites are just the XX named streetlight locations, and we don't have Comstock or Rec or any of those more expensive tower locations. And if I have a way to factor in the cost of the gateway equipment itself versus deploying on maybe a streetlight asset that's already made ready and has power available versus a streetlight asset that's not made ready, and so extra preparation work would have to be done versus an actual telecom site or something like that, whatever the options are. If I can come up with some cost factors for that, what's the relative value of or the relative expense of this pole versus that pole, and how does that compare with the relative expense of the actual gateway equipment itself? Then plugging those into the method for auto selection, I've got the solution that it's looking for is one that meets both my coverage and capacity constraints, so to serve the data demand that I need, and is looking for effectively the cheapest solution that it can find, the best bottom line to get the percent coverage and the capacity needs served. And what we found, especially in working with some of our customers in the utility AMI smart metering space, is that using this automatic site selection can give them network designs. So a site selection that is as much as 20% or 30% more efficient in terms of either the number of gateways, if all gateways are equal, or in terms of the overall cost of the network, factoring that in, we can really reduce that down by a substantial margin. And that's at the same time that you're taking less time to work through this project. Because if you needed to go in and answer the question sort of by hand, well, what can we do with those three more expensive towers? And how many additional streetlight towers would we need? It's possible that you would spend, a week or so coming up with a solution that might ultimately be a much more costly solution, especially if the assumption that you went in with was that you were going to need to have those extra costly towers in there. Um, and so, saving time simultaneously with coming up with a more efficient solution is really quite a win-win. And whether you're using the LoRa technology or NB-IoT or whatever the use case might be, especially if you've got a large scale point to multi-point type of network like this, I really strongly encourage you to build this out in your SignalPro project and give this automatic site selection function a try, especially the method for selection function. And if you run into any trouble with it, if you're having difficulty getting the results that you need or getting it to run quickly enough for the scale of project that you have, please do reach out to us. And again, as customer success manager here, my role is to make sure that you're really getting benefit from the SignalPro software and that you're leveraging these features to help you design your networks more effectively, more efficiently. So if I can help you in doing that, please do reach out. Um, let me get back to my slides here. Oh, there we go. Geez, I don't know why it's not letting me scroll through. There we go. Okay. So the one of the last things I wanted to show here is this coverage graph. And this also shows up, when I'm back here looking at the results, there's a display coverage graph button right down here. And if I go ahead and show that graph, what we're looking at here is the number of sites along the x-axis, the number of gateway sites that we had to place, and what percentage of coverage of the endpoints or the area. So in this one, we're looking at the area. What percentage of the area is covered when we have, starting out at um, let's see, this would be probably two or three gateways, starting one, two gateways. We can cover about 40% of the area with just a few gateways. And we can get up to 80% of the area with, it looks like right around 12 gateways. And this is, every network, every different area that you might design in is going to have a slightly different knee to it. This transition of how much you can cover and how many additional gateways you need to deploy to get that last few percent. Uh, Understanding what that curve looks like can really help you understand your deployment strategy and the financials of that deployment strategy, and at what point that last few percent should maybe look at backhauling some different way or relocating those sensors so that they're easier to connect with. Because that reaching that very last 5% might take a huge number of gateways just because of all these ravines in San Diego. Getting to every last nook of these ravines might take a profound number of gateways. And using this coverage graph, we can understand that. And you could even do a couple different phases of design where I could run this auto placement with a target of 80% and figure out where I should put my first 10 or 12 gateways in order to get an initial deployment with maximum effect. And so this here again, this coverage graph can be really useful to understanding where to put the best sites and or where to put those initial sites, and also what metric, what coverage targets to use in your rollout. So finally, again, I know there's a lot of material here. There are a lot of options available to you in setting up your project and in configuring these automatic site placements. Uh, to get more help, a couple items here. I'm sure you're probably familiar with these, but you can always go to edx.com and visit our knowledge base, or in that same portal for the knowledge base, you can start a trouble ticket. If you're getting results that you don't understand, or you're having a problem getting the software to work the way you need, go ahead and start a support ticket and let our support team help you work it through and point you in the right direction. Um, this knowledge base, this knowledge base has a bunch of good targeted how-to articles, including one on this automatic site placement feature. So if you were to go into this knowledge base and search for automatic placement, you would get an article on how to use the automatic site placement features, just like I just showed you. Um, and finally, you can reach out either through the customer support portal or contact your sales manager directly, whoever your sales contact is, and ask to schedule custom training if you've got a new use case in front of you, or you've got a team of engineers and you want to make sure that you're using SignalPro uh, with the very best practices for that use case. You can always reach out and we can do custom training or just check in with a customer success call. So I appreciate you sticking with me through the fighter jet noises, and I hope you were able to hear me anyway. Thank you for joining today. Oh, it looks like we've got in the question and answer there was a question what's the size of the grid cell when I did that auto placement calculation? That's a good question. I'm not sure myself. Let's take a look. So if I go into studies, define the study grid, I used a 10-meter grid cell for the area wide placement. Um, and I may have subsampled that down to a 20-meter grid cell in the placement, and then a 10-meter grid cell in the finalized area study results. Um, and then there again, I did this both as an area study type of an exercise and also as a point to multi-point with my uh, specific CPE locations. Um, so thanks for that question. That's in case that was interesting in just how I set up the project. Um, are there any other questions? Feel free to use the Q&A panel here in your Zoom webinar interface. We've got a couple minutes here. If there are any other questions, I'm happy to answer those. Okay, well, again, I want to thank everybody for joining the webinar today. And if you have a project in front of you, if there's something that we can help you with, please don't hesitate to reach out to us either at support or sales@edx.com, or again, just go ahead and go on to the customer support portal and raise an issue with us. Um, uh, sorry, I was want to make sure I didn't leave any part out. I think that's it. Again, thank you everybody for joining, and have a great day.